Okay, here we go. So he's cup. Okay, this is the first video for physics I made with my new glasses. Okay, first video for momentum. Yes. All right. Now, what I did on the website was I cataloged all of the existing videos into a table in the website that's self-explanatory. So if you go to the website and you click video links, etc., and you go to the site where the videos are located, they're all going to be identified and cataloged in one place, every video that I made for physics, okay? Now, this is going to be a review for momentum, okay? A review. This is the only review. We have review 1 for momentum. Now, let's talk about the chapter. It's a very short chapter. It's a very easy chapter. There are 3 or 4 major ideas in the chapter. The first idea is that momentum, I use the letter rho, lowercase, equals mass times velocity. Okay, so if something is stationary, if something is static, if something is not moving, does it have a momentum? No. Something that's not moving, does it have a force? Yeah, it does. Of course it does. It has a weight, correct? It has a weight down. It doesn't have a force left or right, but it does have a force. Now, is the momentum, though, 0 for that mass, if it's stationary?
Yeah. Yes.
Yes, it is 0. Okay. So when we discuss momentum, it has to have a velocity greater than 0. You apply it to any mass. Yes? Okay. If we're in outer space and I take an object, we're millions of miles from any planet or sun, and I take an object that's floating with me. Does it have any weight? Does it have weight? No, it doesn't. But does it have mass? Yes, it does. So can it have momentum? It won't have weight, but it'll have momentum, yes? Now, if I take that object and I reverse, and I move it, and I reverse it, am I going to feel the reverse of that momentum? And how and why will I feel that? That brings us to the next stage. Yes, go ahead. The force is pushing it, okay, but it's going at a constant velocity. In other words, I'm moving it at a constant velocity, and then I switch, and I go like that. So let's look at that. Let's look at that switching, okay? Let's look at, is the momentum changing?
No.
It's not changing? Yeah, it's changing. Is momentum a vector?
Yes.
Yes, it's a vector. So can it change direction?
Yes.
Okay, good. So if it's going this way, doesn't it have a momentum?
Yes.
Let's call it positive. Is that okay? Okay. So it's positive. So it has a mass and a velocity, and it's positive. We're just going to assign left to right as positive. Okay? Now, it's going to change direction, and it's going to go this way. What's the direction of the momentum? MV. What's the direction?
Negative.
The direction's negative. Okay, negative. Now, this is momentum, right? It's positive momentum. This is negative momentum, correct? This is initial momentum. This is final momentum. Would you say that that's correct? Is that okay? So do we have a change in momentum? Okay. So we say that the change in momentum equals Is it always final minus initial or initial minus final? It's always final minus initial, okay? Yes? Let me say on the video, so I have documentation, all problem sets are done on separate paper, and the entire problem set has to be done. Not only the exercises and examples have to be done, but all A's and B's under additional exercises. When it says additional exercises, it doesn't say optionally done additional exercises, does it? Correct? You have to do all of it, and all of it on separate paper. Clear? Mohammed? Omar? Excellent. Okay? All right, now. So if I say final minus initial, right? Isn't final negative? Isn't it? So doesn't this equal? Isn't this magnitude the same as that magnitude? Isn't it? So isn't it essentially 2 times the momentum? You're doubling it, aren't you? Let's say the momentum was 10 going this way and 10 going back. What would the change in momentum be? Negative 20. The change would be negative 20. You're doubling it. Clear? So what's that called in momentum speak? When we talk about momentum, what did I just talk about? The concept starts with a B. The concept of bouncing, right? If there's any bouncing going on, you're simply increasing the momentum. If it's an elastic bounce, such as molecular theory, where the collisions are elastic, so you have a bounce that's elastic. If it hits a wall and bounces straight back, you're going to have twice the momentum. So the bouncing is difficult, correct? Now, let's talk about a car hitting a tree and stopping, right? Is there a change in momentum there? Is there a change in momentum? Yes? Let's say that the car came to a stop. And let's say that the car weighed, I don't know, what's the weight of a car? Anybody? 2 tons? 2 tons is good, right? 2 tons? So what's that in kilograms?
Oh, like 2 tons, kilograms. 2 tons.
It's about 1,000. Let's say about 1,000. So let's say, can we say 2,000 kilograms? Is that okay? So 2,000 kilograms? 2,000 kilograms. And let's say it was a terrible accident. Let's say they were going, I don't know, there's some crazy drivers here in the UAE, right? That's not a reflection of the UAE. I think UAE is a wonderful place. But it is a reflection of some of the crazy drivers. Amir, you're from the UAE originally. Would you say that there are some crazy drivers in the UAE? Yeah. I'm on Route 10E, and I'm going 120, 110, and there are people passing me like I'm standing still. It's unbelievable. They're going easily 150, correct? 160. They're going at least that, right? So let's say they're crazy, and let's say they're going 160 kilometers per hour, okay? Right? What is the velocity in kilometers per second for a car that's going 160 kilometers per hour?
Meters per second.
Sorry, did I say kilometers per second? I meant meters per second. Thank you. Nice catch. So let's see. 160 kilometers per hour. Remember, I don't teach unit label conversions. You simply have to know them. There has been more energy spent on the teaching of scientific unit label conversions than anything else, and it's a waste of time to continue doing it into your late teens, so learn it. So I'm going to multiply it by 1 hour over 60 seconds, correct? The hours cancel. And then I'm going to multiply it by what?
1,000.
I'm going to multiply it by 1 kilometer and 1,000
So isn't,
meters. Is that right?
isn't it 3,600 seconds?
Did I say 60? You're so good. Excellent. Nice catch. You guys are on fire today. You guys are on fire. Excellent. Well done, Mohammed. Excellent. Extra credit. Extra credit. Excellent. I like that. I like that. On fire. See, Omar likes extra credit, but he actually has to be listening and watching. You see, that's part of the problem. Right there, Omar. Okay. Oh, I just got his attention. He wants to get some extra credit. Excuse me?
Don't blame me.
No, you're gonna blame the bear, right? The bear. Okay.
Did I get extra credit or he got it?
I didn't say anything.
Kareem got extra credit. No, I don't give extra credit if you were thinking it. Okay? So, could you get that for me, Mohammed, please? All right, so what's that equal? What's that equal?
Extra credit.
What's that equal?
Can I come inside?
No, you may not. I said no. Excuse me. All right, let's make sure this is on the screen. You know, Mohammed wants to be famous. Mohammed, you are already famous. Okay? All right? Okay.
44 meters per second.
Excuse me?
44 meters per second.
44 meters per second. That's what the velocity is.
44.4.
What is it?
44.4.
Can we just say 44? Just makes it easier. Okay, so that's going to equal 44 meters per second. Okay? All right? Easy? So if you're saying you're going 44 meters per second and somebody says, that's not fast, what do you say? It's very fast. Okay? So, what is 2,000 kilograms times 44 meters per second?
88,000.
What does that equal? 44 times 2,000.
88,000.
88,000 kilogram. Can we erase this? Can I erase this a little bit? Is that all right? That's going to be, I'm going to erase this, and that's going to be kilogram meters per second. Those are the unit labels for momentum. Okay, good. So if you're going 160 kilometers per hour, you're driving down 10E, okay, and let's say you hit a barrier. You hit the barrier to an overpass head on, and you stop. What's going to be the change in momentum? What's going to be the change in momentum?
160,000. Oh, no, that's sorry. 88,000.
Right? Won't it be 88,000? Right? Kilometer meters per second? Won't that be the change in momentum if you come to a stop? How long did it take you to stop if you crashed into a barrier? How long did it take you to stop, do you think?
Not like
100th of a second? 1,000th of a second?
0 seconds.
No, you had to stop at some amount of time. So let's say a 10,000th of a second, is that okay?
Yeah.
Is that all right? Okay. So what does this equal? This equals something called, let me just see if it's on here still. This is something called impulse. The change in momentum equals an impulse. Clear? And what does impulse equal? What does impulse equal?
4 times 9.
What did you say?
Never mind.
No, what did you say?
4 and
Force times.
time.
Yeah, excellent. The bear answered. I like it. The bear answered. I like it. So, force times time, which is really, I mean, you got to say, the change in time. It's okay to say force times time or force times change in time, right? Yes? So I want to know how much force. See, this is all going through your body, all of this force, right? Right? Yeah? So let's say, can I erase some of this? And we'll just keep on the board what we need. Is that okay? Omar, you all right with that? Okay, excellent. So let's just erase it all. All right, let's just erase that, and we're going to say change in momentum equals impulse equals force times time. So we're going to say that change in impulse equals 88,000 kilogram meters per second. Okay. Okay, just think, for the Americans in here, just think Philadelphia Phillies. Okay, that's their logo, is a lowercase mu. Okay. So this is going to be 88,000 kilogram meter per second equals force, and you said it's going to be a 10,000th of a second. Is that okay? Yeah? Is that okay? Are we all right with that?
Yep.
Everybody's okay with that? You on board? Yes? No, you're not, Jaffer? What do you need?
I'm not bored.
You're not bored? I said, are you on board? It's an American expression. Are you on board? Teaching international education with American idioms. Okay. I know I use on deck. I said that Omar's on deck. He said, what's that mean? On deck. I used something yesterday or the day before. What else did I use? On deck. Are you on board with that? What else did I say? I said something. They had no idea what I was talking about. Something. American idioms. Weird, huh? Yeah, okay. So then let's calculate the force. Can someone take out their calculator and do that? 88, wait a second, hold on there, Kareem. 88,000 kilogram meters per second divided by 0.0001. So the force is going to be what?
8.8.
880 million.
You're dividing.
Oh,
No,
divided?
No,
Yeah,
still.
that's-
It is.
What's 88,000 divided by 0.0001? I don't want it in scientific notation.
880 million.
880
Million.
million newtons. Now I'm 1,000. I weigh 1,000 newtons. That's my weight, 1,000 newtons, right? Can you imagine having 1,000,000 of me sitting on your head? You'd get crushed.
Pretty badly.
Yeah. So what do you think?
You did.
Yeah, they'll be scraping you. They'll be taking a hose to the inside of the car. They'll be hosing out the car. What's that flowing down the street? Oh, that's Omar. There won't be anything left. Pretty disgusting, isn't it? Isn't it amazing? So what is the function of an airbag? What's the function of an airbag?
To maximize the impact time.
Yeah.
Yeah, I like the way you said that. I like the way you said that.
Extra credit.
The airbag will increase the impact time. This is the impact time. So instead of 1,000th of a second, or a 10,000th of a second, maybe it'll be 100th of a second. So let's say it's 100th of a second. So right away, we can get rid of 2 of those. So now we've reduced it to 8 billion newtons. Still not good, huh? Now the seat belt, maybe we'll do it another 1/10 of that. Okay, the seat belt. All right, so we'll say, instead of that, we'll say that. Okay, so we'll do another 1/10. Okay. Now maybe there's some crunch zones. In other words, the car will fold up. The car will collapse. The front of the car will collapse. When I was a kid and a big car got into an accident, the front of the car didn't collapse. So that meant it bounced. What happens when you bounce? Do you increase you increase the change in momentum, right? You increase the change in momentum, you're increasing the impulse. You increase the impulse by bouncing, you increase the what? The force involved, correct?
Yes.
Yes? And the impact time is instantaneous because you bounced. Yes? Okay. So let's say we have a crumple zone. So now we have it down to a whole second. Okay. So now it's 88,000. Okay.
So shouldn't you put in the top one?
So now it's 88,000, right? So now let's say that, so we did the seat belts, we did the airbag, we did the crumple zone, right? Maybe you have a padded dash. Well, you didn't get to the padded dash. Maybe you have more than one airbag and you're really bouncing around in there. We'll do it another one. Okay? It's still, I mean, no matter what you do, even with all the precautions, you're still 8,000. It's probably going to be more than that, even with those precautions. So, what's probably the best thing you could do for safety? You have the airbag, you have the crumple zones, you have the seat belt, you have padded dashes. What would be the best thing to do?
Don't get in a crash.
Don't get in a car accident, but even better than that,
Drive slow.
don't go 160 kilometers per hour.
Drive
Does that make sense?
It's not that
Yes.
fast.
Yeah?
It's not
Does that make sense?
It's not that fast, sir.
Yeah, 200.
It's 100 miles an hour.
It's not that fast.
Okay.
So we-
I don't know what planet you come from, but to me, if you're in a car, it's pretty fast.
So we drive to.
Now, if you take 20 seconds to slow down,
nothing.
you come to an overpass and you're slowing down slowly and you come to a stop, there's not much force involved, is there? The force is slowly bled away. Bled away. Yes?
Yes.
It's over the long period of time. So you divide that by 20, so all of a sudden you get very little forces involved, and it's over a long period of time. Correct? Yeah? So the best thing to do would be to,
Slow down.
yeah, slow down, man. Slow down. And don't cars strangely follow other cars very closely?
Yeah, they don't have.
And what happens if that car broke suddenly?
Yeah, they don't have feeling for distance.
Yeah, you'd have a pile up and the momentum of the car behind you would be transferred to you. And so you're not just talking about the momentum contributed by your car, but cars that are hitting you are also contributing momentum from their cars. So now, all of a sudden, can you imagine getting hit by a bullet in 5 different directions? Is that going to hurt? Is it going to hurt more than one bullet?
Yes.
Yeah. So you're getting hit by all different sides in this giant pileup on 10E
They'll probably be-
going, or 11E going towards Dubai. Not good. Not good. So now what I've introduced in a sense is when you transfer momentum. So the conservation of momentum. Yes? Let's do a problem, shall we? Let's do a problem. And I'm going to make the problem up based on a problem that is on the video. Remember I made a video for the problem set? Remember? I did the video. How many people, be honest, how many people have watched the lecture video on momentum for the problem set? Just 2 or 3 people? Is it excellent or what? Yes, it's long, but isn't it one of my best? Rauda?
That's really good.
Okay, it is very good. So let's say we have a boat. That's a terrible boat. Okay. Let's say we have a boat. Okay, and we have Amir the bear. Okay, he's here. He's here, and we have Mohammed the fish. Okay, we have Mohammed over here. Okay, Mohammed's taller than Amir. Okay, so the boat is going. The boat is going 4 meters per second. Okay? Is that right? Can we do that? Okay, can we do that? Is that okay? Okay. So, Amir jumps off the back of the boat going 5 meters per second. He jumps off the back going 5 meters per second. Okay? All right, now. Muhammad jumps off the front of the boat at 2 meters per second. Okay? All right? Are you all right with that? Yes? Yes? All right. Now, Amir has a mass of, let's say he has a mass of 100 kilograms. Okay? He's the bear. Okay? All right. And Muhammad the fish has a mass of 60 kilograms. Okay? Yes? I want to know what the final velocity is of the boat. I want to know the final velocity of the boat. Clear? What's the final velocity of the boat? Okay, now, you got the picture? The boat is going this way, and then all of a sudden, Amir, the bear, he jumps off the back of the boat really fast, going 5 meters per second, which is pretty fast if you're diving, okay? I don't know how he did that. Good spring in his legs. He's a bear. He has to climb trees to, get the honey out of the beehives, okay? And then the fish, he's very slow, and he's very fast in the water, but he's very slow in the air. So he's only jumping off 2 meters per second, and he's 60 kilograms. And Amir is the big guy. He's 100 kilograms. Yes? What's the weight of the boat? Excellent question. The weight of the boat is, we'll go crazy. We'll go 500 kilograms. Okay? Is that okay? Yes? Okay, now. So we know that the initial momentum is going to equal the final momentum. Do we know that? Do we know that? You okay? You feel better? Okay, good. Excellent. Right? Do you know that? Yes or no?
Yes.
Okay. Now I'm going to erase everything on the board. Do I need to erase everything on the board?
I don't know.
I can put this down below. This is 4 meters per second. Can you see that? Yes. Okay, so that's 4 meters per second. All right? And we'll say that what makes up the initial momentum of the boat and everything else? What makes up the initial momentum? Isn't it going to be the mass? This is going to equal the initial momentum. It's going to be the mass of Muhammad times the velocity of Muhammad, right? Plus the mass of Amir times the velocity of Amir, plus the mass of the boat, plus times the velocity of the boat. Correct? Is the initial velocity of Amir, Muhammad, and the boat the same before they jump? Before they dive off the boat? Yeah. It's all the same, isn't it? Isn't it?
So is it?
They're all in the boat, right? So can I say that the velocity of all times the mass of Muhammad plus the mass of Amir plus the mass of the boat, right? Can I say that? Okay, now, the velocity of the boat is 4 meters per second, so do this out for me. What is 100 plus 60 plus 500?
660.
What is it?
660.
660. Okay. And what's the velocity?
4.
4 meters.
So 4 times 660
2,640.
equals what?
2,640.
2,640 kilogram meters per second. Isn't that the initial momentum of everyone involved? Yes or no? So what we're going to do is we're going to put right here, we're going to say that the initial momentum is 2,640 meters, sorry, kilogram meters per second. Can we say that? Is that okay? All right. All right, now, let's look at the final momentum. All right, now, it's going to be, so what is the mass of Muhammad? Wasn't that what we're listing first? The mass of Muhammad times the velocity of Muhammad plus the mass of Amir times the velocity of Amir plus the mass of the boat times the velocity of the boat. And the velocity of the boat is what we're calculating. Is that correct? Yes or no? Okay. So, what is the mass of Amir?
100.
Oh, sorry, Muhammad.
60.
60. We know that the masses are in kilograms and the velocities are in meters per second, so we're cool. Yes? You all right over there?
Sorry.
That's okay. And what's the velocity of Muhammad? Be careful. What's the velocity of Muhammad?
2 meters per second.
No.
3.
No. Look, the velocities have to be relative to the river. We're assuming that the river is 0 meters per second.
So 6 meters per second?
So it's 6 meters per second positive, right? You see that? We are assuming, what are we assuming in the problem? Because it's not given. That the velocity of the river is 0.
That the ship moves up, yeah.
So relative to the river, Muhammad, if he dives off the front of the boat going 2 meters per second, relative to the boat, he's diving off 2 meters per second. Right? But relative to the river, he's diving off at 6 meters per second. Correct? And what's this?
100.
This is 100. And what is
1.
Amir's velocity relative to the river?
1.
-1. Right?
Yeah.
4 going this way.
5.
He's jumping off 5 that way. So it's going to be -1. Right? Plus the mass of the boat, which is
500.
500 times the velocity of the boat. Okay? All right, let's do this. So this is 360 plus, right? Plus -100 plus 500 VB. So what's this equal? This equals positive 260. Can we write this over here? So positive 260 plus 500 VB equals what?
2,640.
Equals 2,640. Correct?
Yeah.
Subtract 260 from both sides, you get what? What is, let me write this a little clearer. This is 2,640. So what is 2,640 minus 260? Do it. Is Kareem the only one here? I thought that I was...
So I'm helping you.
So it's 2,308.
No. You're subtracting it.
Yeah.
What do you got?
Yes, sir, it's 2,380.
No, it's also 2,300.
It is 2,380.
500. It's 1,000.
Excuse me.
It's 1,000 something.
Yeah, well, you have calculators, right?
So you didn't
This is amazing.
Yeah, I think it's
Excuse me.
Okay.
1,080.
Yeah,
I'm one
Yeah, he's asking after you subtract 2000.
What is 2,640 minus 260?
2380.
2000.
minus 500.
So take.
No, I'm not suggesting, but I'm not saying you're right or wrong. I'm just getting 5 different answers.
2380.
Yeah.
He's going to the final answer.
Yeah, fine.
What is it?
VB equals.
2000.
No, I don't want VB.
Oh,
2380.
500 VB equals what?
2,380.
2,380, and then VB equals what? What is 2,380 divided by a positive 500?
4.76.
4.76. Excellent. Is that an excellent problem or what? Is that good? So, why did the boat speed up? Why did the boat speed up?
because Amir produced hard.
Amir, what law is that based on? No. Third one, Newton's what? Reaction. Yes? We're off. Good luck on Thursday, right? Be prepared to take the test. It's going to be worth 1,500,000 points. If you fail, you're demoted to 5th grade.
Sir, question.
Although some of you act as if you're in 5th grade.
Sir, Thursday's a short period.
Then you better get it done. Thursday's a short period. We're off.
Love misunderstood.